For this example, we have two cars that are driving towards each other. Car 1's position is defined by the equation s equals 5t squared plus 8t plus 1. Car 2 has an acceleration defined as a equals 4 minus 2t with an initial position of 500 feet and an initial velocity of minus 6 feet per second. We want to find the acceleration of car 2 when the cars meet, the velocity of both cars, v1 and v2, when they meet, the position of the cars when they meet, and the time when they meet. So to start this problem, let's just draw a quick figure of what's going on here. Here's car 1, and it's traveling in a straight line, and over here is car 2. Car 2 is going this way, and we'll put a 2 there, and we'll put a 1 there. That's just to help us kind of visualize what's going on with these vehicles. Let's start by looking at car 1. Alright, car 1 has a position s equals 5t squared plus 8t plus 1. And we know that our velocity is defined as change in position with respect to time. So we can take the derivative of this equation to get our velocity equation, which would be 10t plus 8. The acceleration is the derivative of the velocity with respect to time, so our acceleration is 10. And in this case, we have a constant acceleration for car 1, so that acceleration isn't going to change at all. If we look at car 2, we have an acceleration that's equal to 4 minus 2t. If we integrate that and use our initial conditions, then my velocity equation is equal to 4t minus 2t squared over 2, and at time 0 my velocity has to be equal to negative 6, so I need to add my initial condition of negative 6 on the end of the equation. My position equation is found by integrating my velocity equation, so I get 4t squared over 2 minus t cubed over 3 minus 6t, and I know that at time 0 my position is a positive 500, so I need to add that initial condition on here. Now I have equations to represent position, velocity, and acceleration of both vehicles. In order for me to find the time that it takes for them to meet, I'm going to take a look at these two equations. When they meet, those equations have to be equal to each other. So if I set those equal to each other and solve for the time, then I can find how much time it takes for the vehicles to come together. So let's take the equation from car 1, which is 5t squared plus 8t plus 1, and we'll set that equal to the equation for car 2, which, if I simplify that, is 2t squared minus t cubed over 3 minus 6t plus 500. Now I need to solve this equation for time. So if I collect like terms, on the other side of the equation I've got t cubed over 3 plus I've got a 5t squared here and a 2t squared here. So I bring the 2t over to the other side and I get a 3t squared, and then I look at my t term, and if I bring the minus 6t over to the other side, I get a plus 14t, and then I've got a positive 1 on the left, a positive 500 on the right. If I bring the positive 500 to the other side, I end up with a minus 499, and all of that equals 0. Now I can use a solver on a calculator to figure out what the roots of this equation are, and I will find that the only viable answer is that my time is equal to 8.190 seconds. And that's one of the answers that we're looking for. Now that I know the time that they meet, I can find the velocities of both cars and the acceleration of both cars, and also the position where they meet. So let's start with the position. If I take equation 1 for car 1, bring that down here, and then plug in the time into that equation, then s is equal to 5 times 8.190 squared plus 8 times 8.190 plus 1. And when I solve that, I'll get an answer of 401.9 feet. I can check that by taking the equation for car 2 and bringing that down here and putting in the time. S is equal to 2 times 8.190 squared plus 8.190 cubed over 3 minus 6 times 8.190 plus 500. And if I solve that, I'll get the same answer. So this is my answer for the point where the two cars meet. Next, let's find the velocity of car 1. This is equal to 10 times 8.190 plus 8. This is equal to 89.9 feet per second, and it's going to the right. So there's the velocity of car 1 at the time when they meet. Next, we'll look at the velocity of car 2, which is equal to 4 times 8.190 minus 2 times 8.190 squared over 2. Of course the 2's will cancel there, minus 6, which is equal to a negative 40.3 feet per second. The negative simply means that the vehicle is traveling to the left, so I'm going to write this as 40.3 feet per second to the left. And there's my velocity when they meet for car 2. Finally, I need to find the acceleration of car 2 when they meet. We already know the acceleration of car 1 when they meet. That's up here. It's a constant acceleration problem. But for car 2, my acceleration is equal to 4 minus 2 times t, which is just 8.190, which when I solve that, I will get a negative 12.38 feet per second squared, which is the same thing as saying that I've got 12.38 feet per second squared to the left. So there is my acceleration of car 2 at the time that they meet. So I've got the time that they meet, I've got the position where they meet, I've got the velocity of car 1 when they meet, the velocity of car 2 when they meet, and the acceleration of car 2 when they meet. And that answers everything that I was asked for. So my problem is finished, and I'll denote that with a double underline.